Hello and welcome back. Today I'm going to talk to you more about the science of nutrition, and specifically we're going to answer these two questions. What is reliable nutrition data, and where does that nutrition data come from? So let's take a look at that. Where does nutrition data come from? Here I have a pyramid showing sources of nutrition data, starting at the bottom of the pyramid with case reports, then moving up to case control studies, cohort studies, random controlled studies, practices or guidelines, systematic reviews, and meta-analysis. Let's start out with case reports. A case report is usually a single doctor's report on a case or a small group of cases. These reports are usually early studies, and they can be very interesting, but they're also often very unreliable. Here I have a doctor talking to a patient. If the doctor published the results of that patient's illness, that would be a case report. Next, we're talking about case-controlled studies. What's a case-controlled study? In a case-controlled study, you take people with disease, that have disease, these are called cases, and you compare them to randomly selected controls. These are people who do not have the disease. Then you take those people and you look to see, okay, were they exposed? In this case, I've decided to make the exposure to these delicious looking donuts, or were they not exposed to donuts? Were the diseased patients exposed to donuts, or were they not exposed to donuts? Then a case control study calculates the ratio of exposure to a nutritional intervention or a nutritional problem, and how often that occurs in people with disease, or the odds of that occurring in people with disease versus the odds of exposure to, in this case, donuts, to not having disease in controls. You would suspect an exposure of causing disease if you see it represented at much higher numbers in diseased patients than in controls. So the bottom line is case-controlled studies, takes patients and cases and compares their nutrition to a randomly selected control group. Typically in case-controlled studies, odds ratios are reported and calculated so you can understand how frequently the exposure to a nutritional change may cause disease. Unfortunately, case control studies are a little bit unreliable, particularly because they're prone to recall bias. That is, people with disease tend to recall very clearly if they had an exposure, while people without disease, their memory of the foods that they've eaten in the past tends to be a little more fuzzy. Next, we'll talk about cohort studies. Typically, cohort studies are prospective cohort studies or retrospective cohort studies. Prospective cohort studies follow a group of people for a period of time to see what new diseases develop over that period of time. These studies usually assess risk factors and try to determine if those risk factors are associated with the emergence of disease. One problem that we see with cohort studies is they're a little bit prone to selection bias. Let's talk a little bit more about cohort studies. The classic cohort study, nutritional cohort study, is the Framingham study, which was a study of a group of people in Framingham, Massachusetts. 5,000 people were selected in Framingham, Massachusetts in 1948, and then they were followed. Some of these people were exposed to high blood pressure, high cholesterol, smoking, obesity, diabetes, lack of physical activity, and then it was determined whether any of these people developed disease through time. The Framingham study is still a classic study, and there were follow-up studies in Framingham, Massachusetts in 1971, 1994, and 2002. And through the Framingham study, we were able to identify some major cardiovascular risk factors. This is where most of our advice on avoiding cardiovascular disease comes from. Through careful monitoring, the Framingham study identified high blood pressure, high blood cholesterol, smoking, obesity, diabetes, and lack of physical activity, physical inactivity as major risk factors for the development of cardiovascular disease or heart attacks. Another important source of information are cross-sectional studies or surveys. Cross-sectional studies are usually take a random cross-section of the population, and then they ask participants or survey participants about a variety of factors: demographic, socioeconomic, dietary or nutritional, and then ask some health-related questions. Typically, these studies are retrospective in the sense that you're looking back at the diseases, the health-related problems that have occurred through time. And because of this, they're prone to what's called ecological fallacy, and they're also prone to recall bias. One of the classic cross-sectional studies, and it's an ongoing cross-sectional study, it's called the National Health and Nutrition Examination Survey. A great deal of our nutritional advice comes from this NHANES survey. It's conducted every year in the United States and assesses the health status of adults and children. The NHANES interview includes information about demographics, socioeconomic status, dietary and other health-related questions. So what are the problems with these cohort and cross-sectional survey studies? First off, you have to follow a large number of people for a very long time. This is expensive and time-consuming. Unfortunately, cohort studies are not good for identifying causes of rare diseases, and cohorts are also not very good for identifying slow diseases, things like dementia or Alzheimer's. There are some other issues with cohort studies. One of the typical problems is loss to follow-up. That means the people move around and you can no longer follow them through time, and this can cause a bias in the study population. There's also a thing called selection bias. What selection bias is it's the bias of who we've placed in the study at the start. In this case, in the Framingham study, it would be who actually lives in Framingham, Massachusetts. Do these people represent others throughout the United States? And lastly, these cohort studies often suffer from the ecological fallacy. So what is an ecological fallacy? Here's an example of a classic ecological fallacy. On the bottom axis of this graph, you can see chocolate consumption in kilograms per year per person. And on this scale, you can see Nobel laureates per 10 million people. So if we take a look here at various countries and their chocolate consumption, you can see a pretty straight line here in that the number of Nobel Prizes increases with chocolate consumption in these countries. Now you might think, wow, I need to be eating more chocolate, clearly. But I can assure you that no amount of chocolate consumption is going to win you a Nobel Prize. This really is a fallacy, because what it is illustrating is that countries that are very well off tend to have more investment in science and other areas that they can win Nobel Prizes in, and through that they tend to win more Nobel Prizes. It has nothing to do with chocolate. In fact, it's just an ecological fallacy. Next, moving up towards the high-quality data, we'll talk about randomized controlled trials. These are often called the gold standard of nutritional data. What is a randomized controlled study? Randomized controlled studies are double-blinded studies. That means the doctor doesn't know what nutritional treatment is being given to the patient, and the patient does not know what nutritional treatment they are receiving. In this way, it's double-blinded. This is a good thing in this particular case, although operating blinded is not a good thing. Some of the key elements of randomized control studies are the patients are blinded to treatment, the physicians are blinded to the treatment. Good studies have large study size. They are always prospective. They are set up before you, the ideas are set up before you actually conduct the experiment. The hypothesis is formed before you do the experiment. And they are typically placebo-controlled to avoid the placebo effect, where giving some kind of treatment makes people feel better just because it's being given as a placebo. These studies are very reliable sources of data in general and can generally be trusted. Next, higher up in the hierarchy and the pyramid are practice guidelines. Practice guidelines for nutrition are described in most countries. In the United States, the USDA, the United States Department of Agriculture, provides the best practice guidelines for nutrition. This advice is assembled by a large group of experts and can be accessed at this website here at the USDA. And when you get there, you can read the guidelines for 2015 through 2020 here in this document. The latest is the 8th edition. Last of all, nutrition data comes from systematic reviews and meta-analysis. Systematic reviews are published reviews that are usually written by an expert in the field, and often these are very reliable peer-reviewed papers, publications with great information on nutrition. And lastly, meta-analysis. This is the top of the pyramid. Very reliable studies. Meta-analysis groups together studies, as I'm showing here, study 1, study 2, study 3, study 4, groups those together to form a combined results, and meta-analysis of those results is produced in one single paper, because it's taking a large number of papers, a large number of publications, and putting all of that information together. Typically, meta-analyses are very reliable, and you should trust them most of the time. Thanks very much. I hope you enjoyed this short section on the science of nutrition and where to find it. I hope you'll use this information to make your own decisions about what is reliable and what is good nutrition data as you read the literature. Thank you. Have a great day. This is the references and disclaimer page. The reference textbook that most of these videos follow is Understanding Nutrition by the authors Rolfs and Whitney. I use the 15th edition by Cengage Publishing. Please subscribe to my YouTube channel. It's called Nutrition, Fast and Fun. There's lots of great videos that you'll find there. And finally, there's a medical disclaimer. You should read the medical disclaimer to make sure you fully understand your rights and responsibilities. Thank you and have a great day.